Let's say this is a function. Would you agree that this is a function?
Yes.
By the, very good. I'm going to pick 2 points, point A and point B. I'm going to draw a line segment through those. And I'm going to ask you to determine the slope of AB, knowing that this is this x1 and this is f of x1. And what do you think the x coordinate of B is? Right. And what will be the y coordinate of x2? Good. So just give me the slope, which is actually the average rate of change. There is no dot here. Sorry. Between A and B. Average rate of change of function f of x between A and B. It's nothing else but the slope of this line. What would you tell me to write as the slope of this line? Right. Yeah, it's just we have to use these. It doesn't really matter. It's the same thing. It's the same thing with the difference quotient. It's the same thing with the slope of that line. I want to ask you a quick question. So this is the steepness or the average rate of change between A and B. But what if I connect these 2 points? Which of these two which of these 2 pairs of points will have a steeper or a faster average or higher average rate of change? Which ones? The first one that we determined over there or the pink one? Would you agree? Because the slope is higher. This has a higher slope. The average rate of change will be faster here, higher here than here. Slower, smaller slope, not so acute. Very good. Okay, so let's look at an example now. If you'd like to choose, these problems are on page 279. And we can start with, let's say, 15. And you choose the next one. 15 on 279. We're given a function which is f of x equals x squared plus 2x. We're given x1 equals 3. We're given x2 equals 5. They're asking us to find the average rate of change of this function on the interval 3, 5. 3, 5, so the average rate. RATE. And we know the average rate, we know it's a ratio. Something at the top, something in the denominator. The formula is right here in front of us. The same thing, no change. Basically, the slope of that line. So, can anyone dictate the formula? Anyone? Five minus f of 3. Very good. Over 5 minus 3. Very good. Obviously, that's all we have to do is just plug it in. So the denominator obviously is 2. What about the denominator? Can anyone give us f of 5 and then f of 3? So f of 5 is 25 plus 10, so that's 30. And f of 3 will be 9 plus 6, which is 15. Do we all agree with those numbers?
Wouldn't it be 35?
It is very possible.
No, what's the 5? Isn't that 35?
5 squared, yes, it is 25 plus 10 is 25. How did I get to 30? I don't know. Thank you.
No, shouldn't it be 35? It's 25 plus 10. That's 10, yeah.
So 25 plus 10, 35, yes. Sorry. I wrote 30. My apologies. And let me check now. Now I don't trust myself, and I have to go that back again. So this is 9 plus 6. I think that's okay. One more time, 25 plus 10, 35. Yes, I'm okay now, I think. Once I make an error, I don't trust myself anymore for the rest of the day. You never know. So 35 minus 15, I think it's 20. Now I doubt everything. So 20 divided by 2 is 10. This is the rate of change, how fast the function is changing between those 2 points, 3 and 5. Well, actually, 3 comma 15 and 5 comma 35. That's 10. Do we need another example, or is this clear? Okay, very good. So here's our problem. So we are given a graph of a model, and for military situation some years ago, I guess. I hope it's not true anymore, whatever. I want everyone to be happy. That's all I care about. So, okay, so this point is 0 comma f of 0, and this point is 4 comma f of 4. Another one is 7 comma f of 7 and 12 comma f of 12. Do we want to determine this average rate of change, or do we want to determine this average rate of change? Please choose. We want the first one. So between 0 f of 0 and 4 f of 4. Perfect. So this is problem 28 on page 280. And the points are 0 f of 0 and 4 comma f of 4. The function is given to us. So f of x equals 1.1 x to the third minus 35x squared plus 264x and plus 557. I'll check the numbers one more time. So 1.1 x cubed minus 35x squared, that's correct. 264, and yes, 557, correct. Oh!
Right.
Sorry. We just started and I already said sorry twice. Well, let's see what's gonna keep counting. So for now, I just said it twice. So let's see. We'll never know in an hour and 15 minutes. Okay, good. So we're asked, we picked these two, and we want to determine the average rate of change for this function between 0 and 4. Can anyone give us the denominator, which is the easiest? The denominator is?
4 minus 0.
Excellent, 4 minus 0. Now, what about the numerator? I want to show you a way of doing this with the graphing calculator, please. So in y equals, we will enter the function. Make sure I have to check this all the time because I told you about the deep freeze of this computer, so I have to go back and change the independent variable into the ask mode, just the independent. But you probably still have it in your calculator. So now I go to y equals and plug in 1.1 x to the third and then minus 35x squared. Let me know if you need any help with this. Plus 264 x plus 557. Did we enter the function? Does anyone need help with entering the function? Okay, so now we go to second and table, second function, the blue key, or on some computers a different color, yellow, and table, and just plug in what you want. All we want is what? What do we want to plug in? 0 and 4. That's it. So I don't have to calculate anything. So just go over, hover over this to see all the decimal part. So I only have 4. Sometimes it truncates it. So now we see the entire number. So this is 1,123.4 minus 557. And that's what I wrote. Because f of 4 is 1,124.4 minus 557. And then let's see what we get. So I don't need piece by piece, so I'm just going to determine the whole thing with second and quit. Parentheses for the numerator, let me clear all this. Parentheses for the numerator, 1123.4 minus 557. Close the parentheses. Since the denominator is just one number, just divide by 4 and you're done. So the rate of change of this function between 0 and 4 is 141.6. Remember, this means nothing without a measurement unit. I can tell you I have 3 in my pocket. Do you know what it is? It could be $3, it could be 3 pencils, it could be 3 markers, it could be 3 old coins. So I have to tell you the measurement unit. I don't know what the measurement unit is, but in a moment we'll see. Number, so the measurement unit for the numerator, number of discharges. And the measurement unit for the denominator. What is the measurement unit? Yes. So it's going to be the number of discharges per year. Very good. So please make sure that you put that in. 141.6 doesn't mean anything. Since it's number of discharges, this should not count. Even if I have 0.6, I don't have a discharge, right? So obviously I will consider 141. It's a function also. You could say, but it's a function, it will give you an approximation. That's true too. But if you want to be exact, I will say 141, because the 0.6 is not going to give me another one. There is no way I could say 142. Discharges per year. Okay, this is how we look at the average rate of change of a function between 2 points. If we have measurement units for the y variable and the x variable, we have to mention them. If they are abstract, just x and y, then there is no measurement unit. But here we have a measurement unit for the numerator and the measurement unit for the denominator. So that's why this is a combined measurement unit for the average rate of change. I said that probably some time ago. If you call me and you ask me you're driving, okay, what is your speed? Just look at the odometer and tell me. I will not say 60 miles. That's not the measurement unit for speed. Average rate of change, or in that case, it's instantaneous. Rate of change of distance with respect to time is the measurement for distance, miles, over the measurement for time, hours. So I'm driving at 60 miles per hour. Good. Questions, please? Anything you'd like to go back to? Anything? So I think this is my suggestion. I think we should start the review after I answer your questions, anything you have. I will answer some of your questions or whatever you have on Wednesday, but I'd like us to have the test a week from today. Will that work? We have to try to have our second test either before spring break or immediately after, so we can have time for test 3. So I don't mind if you use the spring break to catch up and review and so on and so forth, but we have to try to finish up the material in the next month before the spring break. So I will probably have to start on Wednesday something else that will not be covered on this test. We'll see. Okay, so what would you like to do next? I'm sorry? D as in dog? Okay, very good. Can anyone walk us through number 1D? Can you give us your left, right? Sorry, the other right. Good. Okay, so can anyone tell us what to do? Anyone remembers the method?
So you have to, it's factor, right?
Subtract 10 from both sides.
Yes, we can do that first. That's not the important part. I can do two things in one step, right?
Get the x by itself.
I can't. It's x squared minus 8x plus 10, and I'm asked to use the completing the square.
8 over 2
8 over 2.
squared.
Yes, how much is 8 over 2 or negative 8 over 2?
Negative 4.
How much is negative 4 squared? 16. This is what I recommend. So you don't have to write it twice, but you don't have to. You can move 10 first and then add 16 to both sides. It's up to you. I accept any method that makes sense, of course. Are we okay with this? Every step? Everyone, please? Yes. Go ahead.
Now let's see how I don't look at the adding system. Or let's see how.
The method?
Yeah.
The method is a 4-step procedure. Step number 1, you identify the middle coefficient, negative 8. Step number 2, you divide negative 8 by 2, you get negative 4. Step number 3, you square negative 4, you get 16. Step number 4, you add 16 to both sides. Better? Yes? Perfect. So now we have to remember how to factor this. And the right-hand side is 6.
So you divide it 8 by 7 and then square it.
And then the result gets squared.
Right. And you got rid of the 10 over. Okay, gotcha.
So what is the left-hand side? This was our first day of classes. It's on the agreement that we signed. And we reviewed factoring. So I expect you to use maybe 20 seconds on this problem. Maybe. So what is the left-hand side?
X minus 4.
X minus 4 squared. What do we do next? Take the square root. Good. What is the next step?
X squared both
Add
sides.
4.
I will never get the solutions if I don't remember something crucial right now. If I don't write it, then I can't get full credit.
Oh, plus or minus.
Ah, that's a different story. So then x equals 4 plus or minus the square root of 6. So as I said, I'm hoping that this problem will not take more than 30 seconds of your time. It should not. Good. Next problem. Does anyone have doubts about this? Bless you. Yes.
Just the top part, the 16.
Yes. Let's go back to your notes because it's very important to see where those problems are. So let's go back to your notes when we talked about the 4 methods of solving quadratic equations. It's very important to refresh our memory and see where this is coming from. So let's go back to solving quadratic equations. I know you have them in your notes. I have no doubt. Solving quadratic equations, factoring, taking square roots, here it is. Okay, so 4 steps. Identify the middle coefficient, divide it by 2, square that number, and add 9 to both sides. It's one of the 4 methods that we talked about. Excellent. Yes. So that's where the method is. So we are solving a quadratic equation. You understand how important it is to be able to identify the type of equation. If I know what type this is, then I should not have difficulties in remembering those 4 methods. Right? And this specifically is asking us to use the method that you know I do not like at all in the sense that I have nothing against it. I don't like it for something like this. I like it for something else that you will see at the end of chapter 2, very much. But not for this. Why? Because simply it alone cannot do the job. Okay, I completed the square, now what? If I don't remember to apply the square root to both sides, I will never get the solution. So it alone cannot do the job. Did we find the notes? Do we know now? Do we understand the procedure? Are we still in the dark with this one? Are we okay? Yes,
Can you-
anyone? Yes? Go ahead.
So I know because the square root of 4 is 16, and
This is
guess
not how we factor. Okay, let's go back. So we're trying to factor this. Let's go back to the factoring strategy, to those 3 methods, 3 columns. Those documents that I gave you at the beginning of the class. So we refresh our memory that exactly, can I just borrow it for 1 second? Here it is. Here are the formulas for, right here at the top, the formulas for a binomial square. So from x squared minus 4 minus 8x plus 16, right here, one of these two. Of course, just the one with the minus in the middle, not the one with the plus. So in math, just everything builds on what we studied before. Everything, just everything. And I'm reviewing with you everything because, you know, we all forget. It's okay. So factoring this is what we did on the first day of classes, and I also gave you that handout of factoring strategy for a trinomial. Are we better now about this? Yes? Feeling better? Okay, I know you take very good notes. I know you're following. I can tell. You're a very good class. Okay, so now pointing this out to you, you know exactly where the problems. Okay, perfect. Okay, next problem. Anything else we would like to see now?
Can we do A on the phone?
On the first page? Yes, of course. Okay, so what type of equation is that? This is the second type of equations that we looked at the very beginning. This is the second type. Rational, very good. So this is a rational equation. Can I lower the temperature a little bit?
Yes.
You know what's going to happen in 5 minutes, right? We're going to all freeze in here. So there's just, I'll try again. Okay, it's a rational. So when you say rational, what goes through your mind immediately?
Getting rid of the bottom, the denominator.
Here's what goes through my mind. State restrictions, factor the denominator, find the least common denominator, move everything to one side, change it into a proportion, solve the proportion, check the answers in the back against the restrictions that I wrote at the beginning. A lot. This is not a trivial problem. So first we have to factor the denominators completely. Then we have to state restrictions. If you're using the method that I presented, you do not have to. But if you do, you have to move this term to the other side. So, again, you find these in your notes at the very beginning. So let's go back to your notes for just one moment. At the very beginning, the very first few pages of the notes, where we solve rational equations. Yep, that's not rational because it doesn't have excellent denominators. That's okay. Oh, okay. Okay. But we had other examples. Somewhere. Okay. Do you see that? These are not rational, these are linear. If they don't have x in the denominator,
These have the,
oh, this one does, yes.
yeah.
This one does. Okay, these, they don't have x in the denominator. Is that clear, what we're trying to do? Yes? I'm only showing you for in case you want to go back and practice and see more examples. That's the only reason I'm showing you. So then I have 1 over x minus 4 minus 5 over x plus 2 minus 6 equals 0. Remember, there is only one left-hand side, only one equal symbol, and only one right-hand side. Be very careful. Do not simplify going to the sides. And now please give me the factored form of this denominator.
X minus 4. X minus
Then you're going to give me two restrictions, mandatory, immediately. The problem should ask you to do so.
X can't equal 4 and negative 2.
Very good. Do you all agree with 4 and negative 2?
Yes.
Great job. So our next step would be, again, you don't have to use this method. If you have another one, I'm happy. Use your own. Then we have to find the least common denominator, which is of course, there are two factors in there, so two factors, both factors have to be in the LCD. No discussion there, x minus 4 and x plus 2. But now remember, do not write this. This will be a terrible mistake. This would be a terrible mistake to write. Is that clear? Because x minus 4 was multiplied by x plus 2. So it needs to be multiplied, the numerator needs to be multiplied as well. X plus 2 was multiplied by x minus 4. So its numerator has to be multiplied by x minus 4. This is the same denominator as the least common denominator. That's why you don't have to write anything, or just write 1 in case you want to keep it uniform and write something for every fraction. Now this will be correct. 1 times x plus 2, which is x plus 2, minus 5 distributed to these two terms, negative 5x and plus 20 and minus 6. Everything divided by x minus 4 times x plus 2. But if I forget to write equal symbol and 0, I will never solve. If I don't write this, then I just have a rational expression. I will not find x. So I have a left-hand side, I have an equal symbol, and I have the right-hand side. So now, combine like terms. This is negative 4x, and this is 22 minus 6, which is positive 16. Everything over x minus 4 times x plus 2. And you have two options. We discussed those two options. You either write 0 over 1, or just say 0, and ask yourselves, when is the fraction 0? The answer is not when the denominator is 0, but when the top is 0. Move 16 and divide by negative 4, and I get 4. But I have a problem with 4, a big one. That's why, bless you, that's why it is mandatory to write restrictions whenever you solve a rational equation. Because you may forget to go back and check. If you state restrictions, you'll say, hey, I see it on the list of restrictions. I can't accept it. Two denominators will be 0, two fractions will be undefined. I'll say no way. And I'll say the equation has what?
No solution.
Exactly. Exactly. The equation has no solutions. I got a solution that was listed under no way. If it's listed under no way, I can't accept it. Again, I think I make it look easy. It's not an easy problem. It's not. We have so many different steps to think about. Factoring, finding the least common denominator, multiplying the numerators by what they need, combining like terms, changing into a proportion, thinking in terms of a fraction can be 0 only when the top is 0, or cross multiply, you get the same thing. Then getting some solution, like x equals 4, and then not forgetting to go back and test against the restrictions. And then say, oops, no solutions.
Can you take that?
Say it again.
Can you take a look at this 1 second, please, to see if this method works?
So you, but why did you say no solution? You didn't state the restrictions, how you did it. So be very careful with that method. Be very careful. Be very careful. You cannot multiply both sides of an equation just by x plus 2 without writing that x is not negative. Because you're saying that you are allowed to multiply both sides by 0, but that's not allowed. That's why you have to state by writing restrictions. Be very careful with that. Okay, next question, please. Anything else?
I convert it to
Which one? This one?
Yeah.
Okay, this one we, first of all, it's a quadratic equation. We have to clean it up and take square roots. Again, I'm hoping that this will not take, how come that from A is C? Probably I removed something from there, I'm sorry. Yeah, that's fine. So this is x plus 4, everything squared equals 9, and you take the square root and get, quiet please, ladies, please, sorry. So then you get x equals negative 4 plus or minus 3, and you have to write the correct solution, separating them. So first, again, this is a problem that I hope you will only use 30 seconds on, maybe not even that. So first you have to clean it up, dividing both sides by 3, and then you take the square root, and then you have to get plus or minus 3, although the square root of 9 you know it's not plus or minus 3. And then move forward to the other side and get x equals negative 7 and x equals negative 1. So you have to separate them because you can simplify. One of the handouts that I like to talk about problem 3 before you choose anything else. One of the handouts that I would like to go back to, which we did not get the chance to work through, actually. I'm looking for one. I know I have one here. Maybe additional. I want the, I'm sure you have it. I gave you the supplement with factoring, simplifying by factoring. Yes? Here it is. This one. I would like to discuss this a little bit. So we can work on problem 3. Okay. You can read this, these instructions. I think they're not easy to read. So let's choose a problem from here. Any problem you want. You also, yes? Okay, so factoring is a major topic, as we know. So let me give an example. Let's say we want to factor x to the 4th minus 4x squared. What will you factor out? Yes, of course you will factor out x squared. How come that I cannot factor out x to the 4th? I want to factor out x to the 4th, can I? No, because I have to choose the smallest of these two powers. We've done that with, not really factoring, but we've identified the equations that are quadratic in form. Okay, and then you have x squared minus 4. And then you continue with x plus 2, x minus 2. Okay. So this is the idea. When I want to factor the greatest common factor, of course I will always factor the smallest of the two powers. I know that this looks way more difficult. It's not. It's pretty much the same thing. And they don't show in this document. It was not, I did not participate in writing this document. So a subset of my colleagues created this document. So the answers are here. I recommend you do all of them. But I would like you to choose maybe one or two for us to look at. And again, I don't care about the answer. So let's choose.
5.
6 and 5. Very good. Perfect. So let's start with 5. So we have 5, 2x minus 3 to the 4th, x squared plus x plus 1 to the 4th, 2x plus 1, and plus x squared plus x plus 1 to the 5th times 4 times 2x minus 3 cubed times 2. Yes, you took me 30 seconds to just copy the problem down. Do you all have this document?
Yes.
Okay. So this was problem 5 from that document. So now, first of all, before I even ask you how many terms we see here, I am going to clean this up. There is nothing I can do to this piece because it's arranged correctly. The coefficient is outside and everything else. But here I have a 4 as a factor in the middle, and I have a 2 as a factor in the middle. I will multiply 4 by 2 and put it in front. So I copy 5, 2x minus 3 to the 4th, x squared plus x plus 1 to the 4th, 2x plus 1 plus 8, x squared plus x plus 1 to the 5th, and 2x minus 3 cubed. At this point, I'm going to ask you how many terms we see here.
Is it 2?
Excellent answer. Thank you very much. Indeed. This is the first term. And this is the second term. Thank you very much. Great job. Okay, now, I see that these two terms have some factors in common. Can anyone name one?
X squared plus x plus 1.
Yes, x squared. That's the first one. The order is not important, but x squared plus x plus 1 is a common factor to both terms. Do you agree?
Yes.
Can you tell me which power will come out?
4.
Indeed, the smallest of the two. Excellent. Is there any other common factor in both terms?
2x minus 3.
Very good. Can anyone tell us power? Very good. Excellent. Is there anything else? No. Very good. Awesome. Something has to come up from here and be written here, and something will come out from here, or be left over from there, I should say better, and it will go over there. So this will come from the first term, and this, whatever I write here, will come from the second term, left over. Can anyone give us the leftover from the first term? This is completely out. From 4, I took out 3, so there is 1 left. So a 5 is left. A 2x minus 3 to the first power is left. And also a 2x plus 1 is left. Are we in agreement? Yes, everyone? Okay, awesome. Now I'm looking at the second term. An 8 has to be inside. X squared plus x plus 1, it had 5, but 4 of them are outside now. How many are left? Yes. And then this is completely out. So I copy x squared plus x plus 1 to the fourth. I copy 2x minus 3 to the third. And now I have to distribute. 2x times 2x times 5. 2x times 1
2x,
times 5.
10x,
Negative 3 times 2x. Negative 6x times 5.
36,
Negative 3 times 1
negative
times 5.
16,
Excellent. Plus 8x squared plus 8x and plus 8. Not finished, because we have to combine like terms in brackets. So we copy everything we see. X squared plus x plus 1 to the fourth, 2x minus 3 to the third, and now 20x squared with 8x squared. 10 plus 8 is 18, minus 30x, negative 12x, negative 15 plus 8, negative 7. Done. Although it looks fantastic and difficult and so on and so forth, if you break it down step by step, you should have no difficulties. I know we chose one more, and then we'll go back to this handout. Any questions on this? How do we feel about it? How do we feel about it? Not too bad, I hope. Long, yes, I completely agree, yes, of course. Okay, so can we move on to 6, or we have questions on 5?
Does it matter if you write it in brackets or the parentheses? 'Cause
No.
the answer may give-
No, of course not. It doesn't matter. You can change that into parentheses. Same thing. So in number 6 now, 2x minus 4, 2x plus 7 cubed minus x minus 4 squared times 3 times 2x plus 7 squared times 2, everything divided by 2x plus 7 to the sixth. How many terms we see at the top? How many? 2 terms. Here's one, here's the other. I don't like the way the second one is presented. So I'm going to copy the first one. Minus 6, 3 times 2, I put the number in front. X minus 4 squared, 2x plus 7 squared over 2x plus 7 to the sixth. Here's what I would like to do. I would like to simplify 3 of these from here and from here, and then maybe 2 of these from both. Is that allowed? Did I lose my mind? Should I do that? What's the verdict? So I want to simplify 3 of these with 3 from here. Yes or no?
Yes. You can do that. How's the denominators?
The answer is never. because that's why I said how many terms we see. So this is one term, and this is the other term. We cannot simplify pieces of a term. We have to wait till we factor and then simplify. We can only simplify factors. Please remember that. It's tempting. That's why I asked. It's very tempting. No question about it. Right? But you can't till you completely factor. Do you remember when we talked about the difference quotient? We had to factor out age at the very end to simplify with age in the denominator. We didn't simplify in part of terms. So be very careful with that. Because as I said, it's very tempting. Perfect. So now, don't touch the denominator, please. So please tell me those two terms at the top. What do they have in common?
X minus 4.
They have 2 in common. Excellent. They have x minus 4 in common. What power?
1.
Exactly. And what else they have in common?
2x plus 7.
W- Excellent. Well done. And remember now, some piece from the first term is left over, and some piece from the second term would be left over. Great job. Thank you. Okay, what is left from the first term?
2x plus 7.
Do we all agree with 2x plus 7? Excellent. Yes? Okay, what piece is left over from the second term?
4.
Careful.
3.
3. What else? Yes?
X minus 4.
That's it. That's it. Now, yes. And I am anxious to do this. Yes, and now I'm allowed because I'm simplifying factors. I simplified 2 factors of 2x plus 7 from the top with 2 factors of x plus 7 from the denominator. That's why I'm left with 4 in the denominator. Yes, I will combine like terms. 2x minus 4. And then we have 2x plus 7 minus 3x and plus 12 over 2x plus 7 to the 4th. And yes, I'll combine like terms to in parentheses. So negative x plus 19. And you already know me. And you already know why. I will factor out negative 1 from this. I don't like that negative in there. Okay, does it make sense? Please say yes or no. You will not hurt my feelings. Does it make